Now we continue with a more complicated structure. I prepare five structure. We are going to learn 5 structure. I'm going to explain to you the concept of functional group. Functional group is it simply means is a type of connection that you have in organic compound. In the case of alkane here, you're going to see. In the case of alkane, there's nothing special about it. You just have carbon and hydrogen, and this carbon and hydrogen are just connected with single bond. But in the case of alkene, and when you see that the name contains ene as a suffix, you're going to have double bond between 2 carbon for that substance, which means each carbon have 2 more extra bond to connect with something else. So this type of functional group is called alkene, means is a double bond. And in the molymorph model, you're going to see this 2 carbon. Between the 2 carbon, they have 2 connection or 2 bonds, 2 covalent bonds, which means each carbon have extra 2 bonds to connect with something else. Another type of functional group is called alcohol. You can recognize the name of an alcohol. You can recognize the name of an alcohol from the name. It contains the suffix OL, like this. It means alcohol, which means the substance contain OH. Functional group. And in the molymorph models, it simply means that substance will contain O and H connected to that carbon. Another type of functional group is called carboxylic acid. You can recognize from the name, it contains oic acid. In this case, we are going to do the structure of propanoic acid. It contains this functional group called COOH. Carbon double bond with O, single bond with O, and O connected with H. It looks like this. Carbon connected double bond with O and single bond with O and H. That's the 4 structure we are going to do today. We're going to draw all the structure one by one. Propane, right? Propane means 3 carbon, and there are no other functional group connected to it, so we just plug in all the hydrogen, which means the molecular formula for this is C3H8. If you count, you have 8 hydrogen. Yes, because prop means 3 carbon. Propene also contain 3 carbon, so we must add 1 more carbon, single bond only. We don't have to do double bond. This carbon already have 2, so you can connect with 2 more hydrogen. this, and we must plug in all this hydrogen, right? So remember, the word prop means 3 carbon, and you have double bond for that. And the Molly-Mott model for that, 2 carbon, because it's alkene, you must make it 3 carbon like this, and plug in all the hydrogen. Yes, so this is a model. You have double bond and 3 carbon like this. Good. And of course the molecular formula for propene is C3H6. The next one, propanol, contain OH, and it must contain 3 carbon. So we must draw 3 carbon connected to it, and the rest, of course, you must plug in all the hydrogen. Right? Again, prop means 3 carbon. The Molly-Mott model for this, very simple. 3 carbon must contain OH somewhere. Propanol, right? Very simple. This is the model for that. Propanoic acid. Propanoic acid, also very simple. Must contain the COH functional group, and total you must have 3 carbon. You already have 1, so we must add another 2. That C in COH is counted when you give name to it. So again, prop means 3 carbon. So we already learned 4 functional groups: alkane, alkene, alcohol, and carboxylic acid. The most complicated one is this type of compound called ester. You can recognize from the name. The name contain this thing, YL and OH. It simply means you must have this structure COO, something on the left and something on the right. This is the thing, C double bond O and O. You have 1 connection on the left and on the right. Now, the word it means 2 carbon. And these 2 carbon must be connected with this O with single bond. So you're going to have 2 carbon. Later we must connect it with. So it means 2 carbon here. Prop means 3 carbon, and that 3 carbon must be connected with C double bond O. We must standardize 3 carbon. And Don't forget to put in all the H. You can do that the last, right? You put all the hydrogen in. So this is the structure of ethyl propanoate. You have 3 carbon on the left and 2 carbon on the right. How to make a model out of this? You have this one, 2 carbon on this O, so we are connecting it here. These 2 carbon connected with this O, and another 2 carbon to make it 3 carbon on the left here, COO, like this. So this is a model of ethyl propanoate, right? So that's how we draw a structural formula for all this organic compound. Don't forget the molecular formula for propanol. Very simple, 3 carbon, so C3H 7OH. Propanoic acid, C2H5 COOH, C2H5. Then you have one more CH. This C is counted when you give the name. And ethyl propanoate, C2H5 COO C2H5. So that's how you give name to, that's how you draw structure for all this organic compound.